Okay, so this is what we have learned in year 10, and that's what I grabbed from year 10 book. Okay, that's a screenshot of the year 10 book. So the general quadratic formula. So we have general quadratic formula as x equals to minus b plus or minus square root of b squared minus 4ac over 2a. Okay, that's a general equation. So if you don't like to solve it by completing square, you can directly pop in a, b, c values and find the solutions. But you cannot avoid completing square because in some case it will ask you to do factorize and you must go through completing squares. Okay, I will give you a general chart about all of these equations represent later. So we have quadratic formula here. And then we have discriminant, which is this thing equals to b squared minus 4ac. Why that can be an important thing? Because we know under square root, we can only put positive values, okay, not negative values. We cannot put negative values under square root. So we put b squared minus 4ac here, which b squared minus 4ac, if it's a positive value, then I can find solution. If it's a negative value, I cannot find a solution because I cannot solve that. You give me a false equation. So when discriminant smaller than 0, the equation will have no real solutions, okay? Because square root discriminant is undefined when discriminant is smaller than 0. If it's positive, I will have two real solutions. Okay, when it's positive, I will have two real solutions because something plus one thing and something minus one thing, that will give you two solutions. But there's a special case when is the discriminant equals to 0. If discriminant equals to 0, something plus a 0 and something minus a 0, that will be the same value. So I can only find one solution out. Okay, I can only find one solution out. So now let's think about use the quadratic formula to solve for x and find discriminant. Okay, so now we have, I missed an x here. That should be 3x. Okay, that should be 3x. So it's a half x squared minus 3x plus 9 over 2 equals to 0. So first, you need to think about, what is the a, b, c value. So a equals to a half, b equals to 3, and c equals to 9 over 2. And you can think about, okay, we have b squared minus 4ac. That can be a really annoying number because all the a, b, c values in fraction form. So what we can do first is simplify that a little bit. I can times the 2 on both sides of this equation. I can times 2 on both sides of this equation. So what I will have is x squared minus 6x plus 9 equals to 0. Okay, so it's not necessary to use the original values. If you can reduce the difficulty of like this question, that would be great. So if you can times a 2 on both sides of this equation, you can make all the numbers become integer. And now the ABC value will change. So a will equals to 1, b will be negative 6, and c will be 9. Okay, do not start to write your whole general formula first because you don't know whether discriminant is greater or smaller than 0. You don't want to write the whole thing out and then find, oh, discriminant is smaller than 0, I cannot work on it. So we can find discriminant first. And to see it's positive, negative, or equals to 0, I can have an idea about there will be one solution, 0 solution, or 2 solutions. So discriminant equals to b squared minus 4ac. And that is 36 minus 36. And that will give me a 0. Okay, I have an idea now. I can only find one solution. Okay, I only have one solution. So my x will equals to negative b, which is 6, plus or minus square root of discriminant, which is a 0. You have found out discriminant before already, so that is a 0 over 2a, so it's 2 times 1. And my x is only 3. Okay, my x is only 3. Okay, so that's how we use this quadratic formula. It's very important, okay? It's very important. Okay, 6 plus 0 is still 6. 6 divided by 2, we have 3. For next exercise is about solving simultaneous linear equation and quadratic equations. Okay, quadratic equations. Okay, this is a question we have learned in year 10, but I see like it's not very well done. Okay, so only 20% of the students can do this type of question. So let's have it here again and do this again now. For this equation, find the values of k such that there will be 2 intersections, 1 intersections or no intersections. Okay, we have a quadratic and we have a linear. There will be 3 cases. So for the first case, I can have no solution like that. Okay, my linear and quadratic, they never meet each other. No solution in this case. Second case, I can have 2 solutions like this. Or in the third case, we can have exactly 1 solution, which is the tangent. This linear is the tangent of this quadratic. So we have these 3 cases. Okay, I just want to show you like graphically there can be 3 cases. But we are not going to solve this by looking at graphs. Okay, there's no way we can solve this question by looking at graphs. So what we can solve is by using algebraic way. We have one equation is y equals to x squared minus kx, and we have y equals to 3x minus 4. So we can solve it simultaneously. I say that's number 1, that's number 2. I will sub number 2 into number 1. We will have 3x minus 4 equals to x squared minus kx. Okay, so what we have, I can move everything to one side. That's a quadratic equation. You should be able to solve quadratic. So I will move everything to one side. Okay, I'll move everything to the right-hand side. I have x squared minus kx minus 3x plus 4 equals to 0. I'll combine x squared term, combine x term, and combine the constant term. So I will have x squared minus k plus 3x plus 4 equals to 0. Okay, so now if you know the k value, you can solve out what is x. Okay, so now we think about backwards. We think backwards. This is a quadratic. Okay, this is a quadratic. I will know the ABC values. In this case, A will equals to 1, B will equals to negative bracket k plus 3, and C will equals to 4. Or you can write B equals to negative k minus 3 is also fine. Okay, anyway. So we will have this. Okay, we will have this. Now let's think about, that's a quadratic. Every quadratic can find discriminant. Okay, every quadratic can find discriminant. So let's find the discriminant first. Discriminant will be b squared minus 4ac. So what is b squared? B squared is this thing squared minus 4 times a times c. What that equals to? The minus will disappear because you have the square and minus 4 squared, 16, 4 squared, right? Why I write that in this form? Because I can use the difference of perfect square formula. I can factorize that easily. Okay, I can factorize that easily. So that will give me that plus 4, a plus 4 and a minus 4. Okay, a plus b and a minus b. Discriminant will be k plus 7 and k minus 1. Okay, why we make it into the factorized form, not the general form? Because I want to solve for 0. How you can solve for 0? By using non-factor law. How we can use non-factor law is in the factorized form. Okay, so that's why I put that into factorized form. Okay, so I want to have 1 solution, 0 solution, and 2 solutions. So now understand, you want to solve quadratic. If you want to solve this quadratic, how the quadratic can give you 2 solutions? Is discriminant greater than 0? How you can have 1 solution from a quadratic is when the discriminant becomes equals to 0. How this equation have no solutions is when the discriminant is smaller than 0. Okay, that's 3 cases. Okay, how you can solve for x? If you can solve for 2x, I will have 2 y values. If you can solve for 1x, I will have 1 y values. If I have no x values, I have no y values. Okay, that makes sense. How you can find intersections. Okay, so, okay, I will list out. So, if I want one intersection, is when discriminant equals to 0. If I want to find 2 intersections, I have discriminant greater than 0. If I want to find no solution, no intersections, I need my discriminant to be smaller than 0. That's the 3 cases. Okay? So that's the 3 cases. So you know, like, your discriminant is k plus 7, k minus 1. Let's say 1, 2, 3. So in number 1, discriminant equals to 0. That will give you k equals to negative 7 and k equals to 1. Okay, either to be negative 7 or k to be 1. Okay, that is easy to think. Okay, number 2, I want discriminant to be greater than 0. In what case that will greater than 0? So it's k plus 7 times k minus 1 to be greater than 0. I want that to be greater than 0. Okay, that's an inequality. Is that a linear inequality? No, it's not. So if it's not a linear inequality, what we can do, we need to sketch the graph to think about that. Okay, so if we want to sketch the graph to the left-hand side, we will have minus 7, and we'll have 1, and we will have this graph. Okay, that's my quadratic. It's a positive graph. We'll have this part of the graph. Let's say we draw the y-axis. Okay, now I need that to be greater than 0, which means it's the y value to be greater than 0. When is the y value greater than 0? It's this part of the graph and this part of the graph. But that needs to be an open circle because I'm not taking 0. Okay? It's all the thing to the top of x-axis. It's greater than 0. Okay, so which x value will correspond to those y values? It will be this part of the graph and this part of the x. And we can see that is k smaller than negative 7 or k greater than 1. Okay, so it's those parts of x will give you a y value greater than 0. If y value greater than 0, is that quadratic to be greater than 0, which I will have 2 distinct solutions. Okay? And to case number 3, okay, for case number 3, I have my discriminant smaller than 0, which means I want this quadratic to be smaller than 0. Again, I will still draw this graph. Negative 7, have 1, have the graph, have this graph like this. Okay, what I need this quadratic to be smaller than 0. What is smaller than 0? It's not including those 2 points, but below the x-axis. Below the x-axis is the value smaller than 0. What x will correspond to those values? That will be the x in the middle of those 2 points. Okay, you can see that quite easy. Smaller than 0 is below the x-axis. Okay, y value smaller than 0 is below the x-axis. And then we want what x value will correspond to that will be the value in between the graph. Okay, so that is the k value in between negative 7 and 1. Okay, in between negative 7 and 1. You cannot take negative 7, you cannot take 1. Okay, it's those values. Okay, so your final answer should be, okay, if it's one intersection, you will have k equals to negative 7 or k equals to 1. If you have 2, right? if you have two intersections, you will have k smaller than -7 or k greater than 1. And if you need you have no intersections, right? I want no intersections. You need to have k in between -7 and 1. Okay, that's the three cases. Okay, so you can see for this question, we combine the whole chapter 3. We solve for inequalities. We need to understand quadratic formula, and we need to think about the important thing about the discriminant. Okay, three things we need to think about. Okay, that's 3J. Okay, think about 3K. Okay, we have 3K. Okay, do we remember when we learned the family of linear graphs? Family of linear graphs, we talk about the linear that is parallel, all parallel, have different y-intercept, but they are parallel. We use y equals to mx plus c to, like for example, 2x plus c to represent that. They all have gradient of 2. And they all can pass through one point, that's another type. For example, they all pass through the y-intercept. I can say that's mx plus 2. For example, they pass through the intersection of 2. And they all can pass through the x-intercept. And we have another equation, x divided by the x-intercept plus y divided by a value b equals to 1. That's the general equation of the linear all passing through the x-intercept. Okay, that's for linear. We only have parallel or passing through one point. Now we have quadratic. Okay, we have quadratic. Okay, family of quadratic polynomials. Okay, so there's more than what we can think about. So for quadratic, they can have, for example, first one, they all pass through one x-intercept. Okay, they all pass through one x-intercept. They all pass through one x-intersections. Say one x-intercepts. Or they can pass through two x-intercepts. Or number 3, they can have the same y-intercepts. For example, we have y equals to ax squared plus bx plus 1. They all pass through the y-intercept 0, 1. For example, they all pass through two x-intercepts. So 2x-intercepts. We can have y equals to a times x plus 1 and x minus 1. They all pass through plus 1 and minus 1. They all pass through that point. Okay, they have scatter graphs in the graph, inverted graph, but they all pass through the same y-intercept. And they can have more about what we can think about. For example, number 4, they all pass through the same turning point. We have y equals to ax plus 1 squared minus 2. They all pass through the turning point -1 and 2. And we can talk about more. Or they can all pass through a general point. Okay, any point. Not x, y intercept, not the turning point, but like a general point on the graph. They all pass through that point. So we have a lot. Okay, we have a lot, maybe 10 types. But those ones are the normal ones we talk about. Okay, that's the ones we normally talk about. So that's when we use those knowledge to find equations for some quadratic. Okay, let's have a look at a general form of a quadratic. A problem passed through the points, those 3 points. I want to find the formula for that quadratic. So there's no x-intercept. There's only one y-intercept. There's no turning point. We need to use the most complex way to find it, which is substitute values into the general equation to find ABC values. But the good thing is we know the intercept. We know the C value must be 5. And then I just substitute another point, 1, 4, and -1 and 10. So I have 4 equals to A plus B plus 5. And 10 will equals to A minus B plus 5. Okay, now you can see we have a plus B and we have a minus B. If we can add those two equations, we will have 14 equals to 2A plus 10. Okay, we have 2a plus 10. So a will equals to 2. 14 minus 10 is 4. 4 divided by 2 is 2. I can find my a value is 2. I can sub a equals to 2 into equation, for example, number 1. I have 4 equals to 2 plus b plus 5. B will equals be negative 3. Okay, b will be negative 3. So 4 minus 2 is 2. 2 minus 5 is negative 3. So b will equals to negative 3. So this equation will be y equals to 2x squared minus 3x plus 5. Okay. For the next example, this is another one example. This is one example. Let's read the top one. The coordinates of the turning point of a problem are 2, 6. I know the turning point, and I know a general point passed through the point 3, 3. So what I can write is the turning point for x minus 2 squared plus 6. Do you think that's correct? Okay, is that my final answer? Can we just use one point to make sure what is a quadratic equation? Even though it's linear, we need 2 points. For quadratic, we need at least 2 points. I only use 1 point, which is the turning point, to find the quadratic equation, which cannot be correct. So always remember there's an a value in front, because that represents the dilation. Okay? We can have so many graphs have the turning point at 2, 6. But like they can be fattest, inverted. They have so many ways, okay, to represent an equation to have turning point at 2, 6. So we need to find which one is this one. We need that a value. The a value represents the dilation of this graph. If you're not writing this a, you only have like dilation, no dilation, which is 1, okay, the standard graph. So you need to find the a value. So how we can find the a value is substitute the points 3, 3 in. Substitute the points 3, 3 in. So we have 3 equals to a, 3 minus 2 squared plus 6 equals to a plus 6. And a will equals to negative 3. So we will have y equals to negative 3, x minus 2 squared plus 6. Okay, for the next one, from the graph, you can see it passed through the point 0, 0. 0, 0 is also the turning point. It's also the turning point. So what we can write is y equals to a x minus 0 squared plus 0. So which is ax squared. Okay, a point passed through the point 0, 0 as the turning point. What we will have is just y equals to ax squared. And I need to substitute the point 2, 5 in. So 5 equals to a times 2 squared, which will give me a equals to 5 over 4. So y equals to 5 over 4 x squared. Okay, the two questions I just want to emphasize that you must have the a in front when you write the equations. And you need to substitute points in to find the value of a. Okay, otherwise it cannot be correct. You can always substitute points back to check whether you have the correct solution or not. Okay, next one. Axis intercepts form y equals to ax minus 1 times x minus 2. So we have intercepts. We have intercepts form. So now I give you that a problem has x-intercepts at negative 3 and 4. And it also passed through the point 1 and 24. We know 3 pieces of information and 2 of that are the intercepts. So that is really important. We will use y equals to a times x minus the first intercepts times x minus the second intercepts. what I have is ax plus 3 times x minus 4. And I need to find what is the a value. Okay, still same thing for intersection form and the turning point form. You always need the a value in front. So we will have 24 equals to a times 1 plus 3 times 1 minus 4. And 24 equals a times 4 times negative 3, which a will be negative 2. Okay, a will be negative 2. So negative 3, negative 12. 24 divided by negative 12 give you negative 2. So y will equals to negative 2, x plus 3, and x minus 4. Okay, if you have turning point, use the turning point form. If you have 2 x-intercepts, use the intercepts form. If you have 1 x-intercepts, do not use intercepts form. You cannot set up the intercept form. You need 2 x-intercepts. Okay, you need information for 2 x-intercepts, and you can write intercepts form. Okay, for next graph, you can see that we have 2 intersects at 0 and 3. So what I can write is y equals to a x minus 0 and x minus 3. So we will have ax times x minus 3. Substitute the point negative 1 and 8 in to find the a values. We will have 8 equals to a times negative 1 and negative 1 minus 3, which will give you a equals to 2. Minus 1 times minus 4 give you 4. So a divided by 4 equals to 2. So y equals to 2x times x minus 3. And substitute negative 1 in. Negative 1 times 2, negative 2. Negative 2 times negative 2 times negative 1 and negative 4, and it's 8. Okay, so check the values. Okay, so I have explained the things here at the beginning. So they will have the same shape, they will have 2 x-intercepts, they will have 1 x-intercepts in common, they will have same y-intercept, they have same turning point. That's all the things I have explained. I just give you a formula to talk about that. Okay, so the last one is quadratic modeling. So for this question, it's an easy one. So the bending moment M at each point on a single beam used a bridge construction is given by this formula, where M is the width of the beam, 1 is the length of the beam, and x is the distance from the end. Okay, so that's the L. Okay, L is the length of the beam. So now give you L equals to 13, W equals to 16, and capital M equals to 288. Calculate the value of x. So basically just substitute all those points in. So 288 equals to 16 times 13 over 2 times x minus W is 16 over 2 times x squared. So 288 equals to 8 times 13x minus 8x squared. I can see that I think we all contain 8. Okay, I can divide 288 by 8, which I will have 36, and we have 13x, and we have x squared. I can make that x squared minus 13x plus 36 equals to 0. So what I want to show you in this question is think about how you can simplify your calculation, how you make this easier. So you will have x minus 4 times x minus 9 equals to 0. So x will equals to 4 or x will equals to 9. You can see 36 can be 4 times 9, but you need a negative 13, you need negative 4 and negative 9. So you will solve for x equals to 4 and x equals to 9. Okay, I'll upload the solution online so you can see all what I write here. Okay.